state model, button 3 state model. So here this model captures the crucial distinctions among various pointing device like mouse, light pen, etc. So we are going to capture the how the model makes the transition from one state to another state. So how we are going to model the transitions from one state to another state. So that is given in three-state model. So here moving the mouse with no buttons pushed normally moves the cursor. So without pressing the mouse button, if I just move the mouse means it is like just moving the cursor. Okay, so this tracking behavior we say it as state 1, and when I click, okay, when I click on the button and then move the mouse means it will take to another state. Okay, so that is termed as state 2. So look at the diagram here. So without pressing the mouse button, if I am moving means that means I am just making a tracking behavior. I am just moving the mouse without any action performed. So that it is assumed as state 1. And when I click the mouse button and then if I am moving means in that case it is dragging the object. Okay, when I click the mouse button and I move means it is dragging. So that is another state 2. Okay, so your mouse transition is moving from one state to another state. So this is how we will model. As you all know, model means you're going to represent it in a maybe a graphical format or maybe a pseudocode, something like that. In this case, it is a graphical format. So we have modeled the mouse transition. So how we are moving from a tracking to a dragging state. So this is how you will represent. So when initially it will be in state 1, that is tracking. So when I press the mouse button, it will be moved to the dragging state, and when I release the mouse button, again it will come back to the state 1, dragging state. Okay, so this is how you will represent in a 3-state model. So let us consider we are having a light pen with a button. It behaves just like a mouse. Okay, so when a button is not depressed, that is if you are not pressing the button, then it is in state 1, that is tracking state. Okay, so when the button is down means then it moves to the dragging state, that is state 2. And in light pen there is another state when the light pen is not touching the screen, that is no action is performed. When the light pen is not touching the screen, in that case it is state 0. So here for the light pen there is 3 state. So when the light pen is not touching the screen, no feedback, that is state 0. When it starts touching the screen without the button pressed means it is in tracking state, and if you have pressed the button means it is moving to the dragging state, and if you release the button it comes back to the tracking state, and if you move the light pen from the screen, remove the light pen from the screen means it will come back to the state 0. Can you understand? This is the transition diagram, state transition diagram, how you're moving from one state to another state. You are representing it as a graphical representation. State transition diagram, I hope you would have learnt in your OOAD and all. Okay. Can you understand this one, ma? Transition from one state to another state. So we, as I told you already, we will be using Fitts law for calculating the time taken. So Fitts law is given by the formula is a plus b log 2 d by s. D is the distance and s is the size. Okay, so plus 1. So here A and B is the constant. It depends on the pointing device which is used. Okay, so the A and B will depend upon the pointing device. So you look at the table here. If your pointing device is a mouse means, then the constant A is minus 107 and the constant B is 223. Whereas if you are using a trackball means the constant A is 75 and the constant B is 300 millisecond. This is for pointing, that is state 1. If it is for dragging means, in that case the constant value A is 135 and B is 249 for mouse. And if you are using a trackball, then the A value is minus 349 and the B value is 688. Can you understand? So for calculating the time, we will be using the Fitz's law, and Fitz's law is based on the size of the object. Okay. And here the constant A and B will depend upon what type of device you use, and this is the constant value. And based on the state also, for pointing there is a different constant value, and for dragging state there is a different constant value. So using this formula we will be calculating the time. So let us see how to calculate the timing constant for the previous example. So in the previous example for the close method, uh, let us recall the method. We had two options. That is, one is you have to choose the file. You have to choose the menu and you have to click on the close. Okay. So let us see here. Let us take that example using close method. Let us not go for the keyboard control W method. Let us assume close method. In that case, for pointing the menu bar, if we are using the mouse means the constant will be 107 and 223. So in that case the time taken is 664, and for pointing to the option the time taken is 713 milliseconds. And if we are using a trackball, then in that case the time taken for pointing to the menu is 1113 millisecond, and for selecting the option close the time taken is 1248. So in this case you can come to a conclusion which will be better, which device will be better. So from this calculation you can easily find out that mouse is taking less time, 664 millisecond it takes for pointing to the menu, selecting the menu option, and for clicking the option it takes 713 milliseconds. Whereas if you go for a trackball it is taking more time. So we can find out which is better. Okay.